Hello and welcome to the second video in Module 1. We're going to start with Example 2. At the end of the first video, I asked you to read through Example 2 and Example 3 on your own before continuing with this next example. Hopefully you've done that. Example 2 says to determine what the key terms refer to in the following study. The study was conducted at a local college to analyze the average cumulative GPAs of students who graduated last year. Fill in the letter or phrase that best describes each of the items below. The population would be all students who graduated from the college. It can be a little bit confusing because A is talking about the students who attended the college, but we specifically want only those that graduated last year. The statistic is a value or characteristic that describes a sample. In this case, it would be G. It would be the cumulative GPA of students in the study who graduated from the college last year. Parameter, again, is a characteristic or value that describes a population. In this case, it would be E, the average cumulative GPA of students who graduated from the college last year. So again, we're talking about all of them versus in G, just those in the study, difference between statistic and parameter. A sample would be letter D, a group of students who who graduated from the college last year, randomly selected. We're talking about a group or a portion that were randomly selected of those that graduated from the college. A variable is a type of data value that's being collected. In this case, it is the cumulative GPA of any one student who graduated from the college last year. And our data will be our actual GPAs. So C is our actual GPAs. Example 3 gives us a few different examples of samples being taken from a population and asks us whether or not a representative and random sample was done. If there is not a random or representative sample, it asks us to identify the sampling error. So basically what we're looking for here is the answer to the question simplified. Is anyone excluded? So in example A, there is an exclusion of any male who is between 18 and 30 years old who did not attend college. For example B, it's a pretty good example of a representative and random sample, but it really depends on what is meant by a telephone directory. Are the researchers talking about a specific telephone directory for a closed and gated community in which every single member of that community is listed in the telephone book? Or are they talking about like the yellow pages or the white pages in which many people opt out? Also, in the common age that we live in, not everyone has a home phone number, so it depends again as to whether or not that telephone directory would include cell phones or mobile phones, or if it is only specifically home phones. So it really depends on what type of telephone directory we're talking about here. For C, this one is one of the best ways of selecting a random sample from a population. Every single person in the local township or a resident of the local township is assigned a specific value. Therefore, they are all, every single one of them, potentially involved in the study. So no one is excluded in any way, shape, or form. And example D is, again, another one of those gray area ones. It's a good example of a representative and random sample. However, the one of the 12 entrances is where it could be a potential issue. That one entrance that they're going to be studying from, it could really sway or bias or change the outcome of the sample depending on whether or not that that entrance is near the food court or near public transportation or near the parking garage, or is it an employee entrance? If they could randomize that entrance as well as randomize every 10th shopper, then that would be the best way of selecting a sample from this population. Now, I know I went through those two examples rather quickly. Again, I was asking you to read through those examples on your own before you started watching this video, so hopefully you did that. Hopefully you were able to take the time to do that. Moving on to some more definitions, we have a variable, A variable is a type of information, usually a property or characteristic of a person or thing, which is measured or observed. So basically, it's anything that we are going to measure or observe of an individual from a population. A categorical variable places the variables into specific groups or categories. This is also known as qualitative variables. Numerical variables take on numerical values, and they all have a specific order. That's going to be an important thing for us to try and distinguish between a categorical or qualitative variable and a numerical or quantitative variable, is whether or not they have a specific order. Now we have an example here. For example 4 says, would a set of social security numbers be categorical or numerical? Well, again, social security numbers have numbers in them, but they're not numerical in nature. They do not have a specific order. If we try to arrange your social security number in an ascending version from my social security number, or if we try to take the average social security number, it wouldn't make any sense here. So a set of social security numbers would be categorical. Since there's no value assigned to them, they cannot be ordered or used in computations such as mean, therefore they would be categorical. What about zip codes? Well, again, basically the same explanation. Since our zip codes are not arranged in any specific order, they are not numerical. However, for age, that can be arranged in a specific order. We can arrange the age of folks in a room. We can arrange the age of students in a class. We can arrange the age of vehicles, whatever it is that we're talking about, in an ordered fashion from oldest to youngest or youngest to oldest. So these would be numerical. Take a second here to pause the video and make sure that you understand where I'm distinguishing between zip codes being categorical and age being numerical. All right, moving on, we can now break numerical variables into two different categories. Discrete variable would be any variable that can take on a limited number of values. I'll explain that in a little bit more detail in a minute. Oops, I put that in the wrong spot. Sorry. For example, the number of posts someone makes on a social media platform. These are usually the result of a counting process or a numbering process. Continuous data is numerical data that can take on an infinite number of possible values. An example would be a person's weight, because the measurement can assume any value between two numbers. These are usually the result of a measurement process. So the quick way of talking about discrete versus continuous, well, first of all, again, these are both numerical variables. If we're talking about numerical variables, we're talking about values that have a specific order. If we're talking about categorical variables, we do not apply discrete and continuous. Discrete, again, is generally the result of a counting or numbering process, and continuous data is usually the result of a measurement process. This is the easy way of remembering these. I'm going to pause the video in a minute and let you guys try working on example 5 and example 6. Please read through examples 5 and 6 before moving on to video number 3.